Okay, my name's Mr. Boyer, and I'm here wearing a Superman shirt today because I think math is super, so hopefully you will too. But today we're going to talk about writing algebraic and numeric expressions, which algebraic expressions and numeric expressions are basically just numbers and symbols that are connected with operations like addition, subtraction, multiplication, and division. And sometimes we also have letters in there, and the letters are known as variables, okay? So let's see if we can put some numbers and letters together and translate them into expressions. So first I have 3 more than x. So that means I take x and I increase it by 3. I make it 3 more, so I do x plus 3. And as we go through this, let's also try to be aware of whether we keep the same order that we read or whether we change the order. So for example, in the first one I had x and I wanted 3 more than that, so I wrote x plus 3, so the order changed. Now because this is addition, it doesn't matter so much whether you write x plus 3 or 3 plus x, but sometimes it might make a difference. When you subtract, it makes a big difference. So just be aware of whether the order changes or stays the same depending on what words you're dealing with, okay? So the next one, x more than 3. So I start with 3. If I want x more than that, I add x. So the order changed again for the words more than. The order must change. 3 less than x. So you start with x and you want 3 less than that, and the order changed, and for subtraction that makes a big difference because x minus 3 and 3 minus x are not the same. Okay, the difference between x and 3. Well, I have x and I have 3 and I want to find the difference between them, so I subtract. That means subtraction. And so the order stayed the same here. Okay, so the order stayed the same. So when you use the word difference, apparently the order stays the same. So difference makes the order stay the same. That sounds a little weird, but that's okay. X less than 3. I start with 3. I want x less than that, so I subtract. Order changes again. The words less than means the order change. The difference between 3 and x, well, I have 3 and I have x, and here's their difference. And the order that I read it in was the same order that I wrote it in. N subtracted from 2. So I start with 2. And if n is subtracted from 2, I do 2 minus n. So the order changed. It seems like most of the time the order changes here. Okay, and then n subtract 2 means I start with n and I subtract 2. And here the order stayed the same. So you got to be really careful here because subtracted from, the order changes. But if I just say subtract, the order stays the same. So really pay attention. You may have to memorize these, you know, and there's nothing wrong with having to do that if that's what it takes. Okay, x or 5 less than z. So I start with z. I want 5 less than that, so I subtracted. The order changed. Okay, now here is one more. This is actually kind of a sneak preview of something you're going to do in another chapter. But I have 5 is less than 3. Now that's actually not an expression. That's actually an inequality. But the reason that I put it here is because I want you to see that by adding one little letter or one little word, the meaning is completely changed. If I say 5 less than z, I subtract 5 from z. But if I say 5 is less than 3, well, or actually I should say z to be consistent. Let me make that z. So if I say 5 is less than z, that means I have z here. Oops, that means I wrote it backwards. That means I have 5. I have the less than symbol, and I have z. Okay, I like to put little marks on my z's. I don't know why. So 5 less than z means z minus 5. 5 is less than z is an inequality. Just using the word is makes it a completely different thing. Again, this is not an expression, this is an inequality, but I wanted to include it just to show you that one word can completely change the meaning. So really watch that. Okay? The product of 7 and r is 7r. The quotient of 7 and r, that means divide, so you could do 7 divided by r. Or you could do 7 over r, because as you may or may not know, fractions mean division. Actually, my cousin taught me that when I was a kid. She said fractions mean division. So I never knew that before, but then I did. 7 more than 3 times a number. Okay? So 7 more than 3 times a number means I have 3 times a number, and 7 more than that, I just do plus 7. And you got to be really careful, because if you look over here, I have 7 is more than 3 times a number. Just by adding the word is, we don't have an expression anymore. That's also an inequality. So 7 is greater than 3 times a number. Okay, so just be aware, the word is can completely change everything. You don't have an expression if you have the word is. Okay, 2 subtracted from 3 times a number. So I have 3 times a number, and from that I'm going to subtract 2. Okay? So 2 subtracted from 3 times a number. And notice the order changed here. And the order changed there. And the order stayed the same for these two. Okay? 2 minus 3 times a number. 2 minus 3 times a number. Notice here the order that we set it in is the same as the order that we write it in. And then let's look at this one. The quotient of 4 times a number and 7 less than a second number. So the quotient of 4 times a number, that's one thing. And 7 less than a second number, that's my second thing. So the quotient of these two things. So whatever these two things are, I'm going to divide them. So I'm going to put a division symbol. And it says the quotient of 4 times a number. So 4 times a number, you could say 4n, or you could do 4x, whatever you want. And then here I have 7 less than a second number. So I need to use a different letter. I'm going to use m, and 7 less than that, I would subtract 7. Now one thing I need to do, because these two things are kind of bound together, because I'm saying 7 less than a second number, I need to put parentheses around this. Now you don't have to do that if you write it as a fraction. So you could say the quotient of 4 times a number, so you put 4 times the number on top. And then after the and symbol, you put 7 less than a second number. So you could do m minus 7. And here you don't have to worry about parentheses. But in this one, if you're going to write them in a line, you would. I actually prefer writing it like this rather than writing in a line, because writing in a line is kind of, I don't know, it feels kind of babyish to me, so I don't know. Okay, the product of 4 and y minus the quotient of 3 and x. So I'm going to take the product of this and the quotient of this, and after I'm going to keep these two bound together and keep these two bound together, and then I have subtraction. So 4 and y, there's their product. Quotient of 3 and x. Well, you could write it 3 over x, or 3 divided by x if you wanted to, but you'd have to use parentheses. And then you put the minus. Okay? Or, like I said, you could do it this way. 4y minus, and then 3 divided by x. But if you're going to do it that way, you need parentheses. Alright? So, now let's go in reverse. We're going to translate into words, and there could be more than one answer. I would probably do this as 3 minus x. It's usually, I think, the easiest because the order stays the same. You could do x subtracted from 3 if you want to change the order. You could do the difference between 3 and x, so difference between 3 and x, whatever you want to do, okay? Here, you could do plus, you could do add. I'm just going to use the sum. So I'm going to say, or you could do 2 times a number plus 5. But I think I'll do the sum of 2 times a number and 5. Okay, so I have 2 times a number and 5, and I take the sum of them. Okay, and then here, this is a product. It's multiplication. You could say 4 multiplied by n multiplied by m. I think I'm going to write this as the product of 4 and m and n. And there are other ways you could do that also. Okay, so that's kind of get you started there. Variables and expressions. We'll do a little bit more in just a second.